Welcome to my channel. Today in this session, let us discuss about the frequency domain specification. Already we have discussed about the time domain specification, and also we have seen some problems, examples related to that. And also we have discussed about some MCQs, gate MCQs. So here we are going to discuss about the frequency domain specification. In case of frequency domain specification, today we are going to see about the four different specification and their definitions and the magnification curve which identifies the specifications. Okay. So with relevant to this, in the upcoming session, let us discuss about some MCQs and also the correlation between the frequency domain specification and the time domain specification. And the frequency domain specification is needed to describe the system performance. System performance is described by the means of frequency domain specification. Also, the system performance is described by the means of time domain specifications also. So, time response is defined by the means of time domain specification, and here the frequency response is defined by the means of frequency domain specification. And to define the specifications, we are going to have an four different characteristics. That means the peak resonance MR, resonance frequency omega R, and the bandwidth BW, and the cutoff. So these four characteristics are defined by this magnification curve, which is drawn in between the time as well as the omega. Okay, so the maximum output is denoted by the MR, that means the peak resonance, and the cutoff frequency is provided by the omega C. In the magnification curve, we are supposed to note that at zero frequency, the time will be equivalent to 1 and the bandwidth will be equivalent to the cutoff frequency. This is very much to be noted while having an analysis by the means of frequency domain specification. Okay, and in frequency domain specification, let us see the definitions one by one. The first definition is peak resonance. This peak resonance is nothing but the maximum value of peak omega is called the peak resonance. In case of time domain specification, we will specify this as T of S. That means that maximum value of T omega, which is equal to the modulus of G of J omega. G of J omega is nothing but the system which we are going to have the analysis divided by 1 plus g of j omega h of j omega. The magnitude of this, that means the magnitude of the system is given by maximum magnitude of the system is given by the term peak resonance MR. The maximum value of T of j omega is called the peak resonance, and it is represented by the notation MR. And it is given as the definition that the magnitude of MR indicates the relative stability of the feedback control system. That means the magnitude determines the relative stability. For the larger value of MR corresponds to large peak overshoot in the step response. For the provided step response, the MR corresponds to large peak overshoot, and usually the MR value must be in between 1.5, 1.1 and 1.5. So, the peak resonance, the maximum value of the response of the provided system. Its magnitude is provided by the term peak response MR. And peak response represents the relative stability of the feedback control system, and it must be in between the 1.1 and 1.5 value. If it is that, it is said to be as the peak resonance value. Okay, this is the first term which defines the frequency response of the system. And next is resonance frequency. Resonance frequency is given by omega R. In this frequency response curve, it is denoted here. For the provided maximum MR, we have a resonant frequency omega R. And this resonance frequency is defined as the frequency at which the frequency peak resonance MR occurs is called resonance frequency, as said earlier by the magnification curve, right? So this only it represents that for maximum value of MR, we have a resonant frequency omega R. This is defined here. The resonance frequency omega R is nothing but the frequency at which peak resonance MR occurs is known as the resonance frequency. And next we define the next term, that is nothing but bandwidth. The bandwidth, while defining the bandwidth, it is defined as the range of frequencies over which M is equivalent to the or greater than 0.707 times of its magnitude. If it is so, such a term is known as the bandwidth. And this bandwidth has some of the characteristics. The bandwidth, what does the bandwidth says? The bandwidth indicates the noise filtering characteristics. Bandwidth indicates the noise filtering characteristic. Bandwidth also represents the measure of properties of transient response. So these are the two cases which is identified by the bandwidth. Bandwidth is nothing but it is defined as the range of frequencies over which M that is equal to or greater than 0.707 times of its magnitude. Bandwidth indicates that it is nothing but a noise filtering characteristics, and also it gives the measure of properties of the transient response. Okay, and in this case, for a larger bandwidth, if a system has larger bandwidth, it corresponds to the faster rise time. There will be a greater rise time. And if the bandwidth is small, the time response of it will be slow and sluggish. These are the 2 points we need to keep in mind while considering the bandwidth in case of frequency response of any system. Okay. Bandwidth corresponds to the fast rise of time, and also if the bandwidth is small, it tends to a time response will be very slow and sluggish. Right? These two cases are also used in the case of adjective. And next, the lowest case of definition in our time response specification is nothing but it is cutoff rate. Cutoff rate, that means as defined by the means of the magnification curve. So this is known as the cutoff rate, and this cutoff rate is not an adequate indication for the characteristics of any system to distinguish in the case of signals from the noise. Okay, so in order to have an adequate indication, it is necessary to perform an term which is nothing but cutoff rate of frequency of response at higher frequency. The term represents the necessary specification for any frequency response of the system to have an response at higher frequencies. Okay, so a steep cutoff characteristics results in the means of larger MR and with low stability margin. This is to be kept in mind while defining the cutoff frequency, right? A steep case causes a larger MR, and also that MR in the sense larger magnitude of peak resonance. It means it leads to a low stability. So today we have seen about the two different characteristics which define the frequency response of the any system. And let me summarize once again. Initially we have started with the means of peak, the magnification curve of the system, and the magnification curve which defines the response of any system, in which we have seen the peak resonance case, bandwidth, resonance frequency, and the cutoff rate. Peak resonance case is nothing but maximum value of T omega is known as the peak resonance of any system. It is defined by its magnitude of T omega. Yes. And It relates to the relative stability of the feedback of the system. And coming to the case of resonance frequency occur when the frequency at which the peak resonance MR occurs is maximum. And also coming to the next case, it is nothing but the bandwidth which is equivalent to the 0.707 times of its magnitude. And bandwidth has its two different characteristics, and also the response of the bandwidth in any system is that if the bandwidth is larger, the faster will be the rise time. If the bandwidth is small, the rise time will be rise time response will be sluggish, and also it will be slow, right? The reason for undergoing for the last term, that is a cutoff rate, is to have a distinction in between the noise and the signal, and at the same time the cutoff rate provides the response of the higher frequencies. Whenever the cutoff rate have a steep response characteristics, the peak resonance will be larger. At the same time, the stability of the system will be low. So, we have discussed about the characteristics of the frequency response of the any system, and also the different terms which define the characteristics, and what about the response of the terms in any system. Okay. So, with this, let us also discuss some example relevant to this four characteristics in the upcoming session. If you like this video, like, share, and subscribe. Thank you.